next topic in 9th as well as in 11th class syllabus is speed and the velocity. So I'll be talking about brief definition and of speed and velocity. Then we'll be moving towards its graphical part. Okay. Speed, as my students in my last lecture, I was talking about the distance. Distance is the total path covered by an object. Okay. Does not have any direction, so that is a scalar quantity. Remember, the speed is basically the rate of change of distance. Distance covered by a particle with respect to time. Yeah. Distance traveled with respect to time. Time taken. Okay. So from this equation we can write, since distance is having unit of meter or centimeter, so the speed will be having unit equal to meter divided by second, that is meter per second or centimeter per second. And remember students, since distance is a scalar quantity, so speed is also a scalar quantity. Yeah. So also remember, this speed is having dimensional formula of m naught L1 t raised power minus 1. Yeah. So depending upon the motion of the particle, what type of motion the body is executing, the speed can be divided into two categories. One type of the speed is known as uniform speed, and the second type of the speed is known as non-uniform speed. Yeah. If the particle covers equal distances in the equal intervals of time, we call the speed is the uniform speed. On the other hand, if it covers unequal distances in equal intervals of time, or vice versa, yeah, exactly, so that is known as non-uniform speed. In non-uniform speed, my students, what we calculate? We calculate average speed. Average speed. What is the average speed? If speed is non-uniform, or we calculate instantaneous speed. Okay. What is basically average speed? Average speed is total distance covered divided by total time. Yeah, exactly. Total time. Total distance covered by total time will give us average speed. And remember, the average speed is having same units as that of the speed. Okay. Then there is instantaneous speed. Instantaneous speed is the speed of the particle or the speed of the body at any instant of the time. Yeah, exactly. So in order to derive the expression for the instantaneous speed, let delta x, delta means small, okay, delta x be the distance covered by a particle in small interval of time, delta t. Okay, we can write here instantaneous speed is equal to, yeah, it is distance covered by time, so that is delta x by delta t, when limit of this delta t tends to 0, we call it is dx by dt. And the students from the 11th class know that it is basically differentiation of, yeah, displacement with respect to time. So remember, instantaneous speed is first derivative of displacement. Yeah, when we will differentiate displacement with respect to time, we'll get instantaneous speed. And the instantaneous speed is also having the same units, same dimensional formula as that of speed. So, if the body is having uniform speed, what will be its instantaneous speed? Okay, the speed of the body. Okay. So my students, here let's talk about these some special cases. If S1, S2, S3 are the distances covered by the bodies with velocities V1, V2, V3, then what will happen? How we can calculate it is average speed. Average speed is here calculated total distance, since average speed is total distance divided by total time. But here we don't know the time. Firstly, we want to calculate what are the times in these different intervals. Okay, let T1 be the time. We know one equation, since velocity or speed, just now we were talking about, is distance by time. So time is equal to distance by velocity. So T1 will be equal to S1 is the distance which it has covered with velocity V1 divided by V1. Yeah, so this will give us T1. Similarly, T2 will be equal to S2 by V2. T3 will be equal to S3 by V3. So, average speed in this condition will be equal to total distance, that is S1 plus S2 plus S3 plus so on, divided by T1 plus T2, that is S1 by V1 plus S2 by V2 plus S3 by V3 plus so on. So in this case, if S1 is equal to S2, that is, if the same distances are covered by the particle with different velocities, S1 is equal to S2 is equal to S, say. So try to remember this special case. Different distances are covered by the particle with the, same distances are covered by the particle with the different velocities. Under those conditions, the average speed will be equal to, yeah, S1, S2, so that is S, so that is equal to 2S divided by, this is S by V1 plus S by V2, that is 2S by S common nikal ke 1 by V1 plus 1 by V2. S and S will go, that is 2 times V1 V2 by V1 plus V2. This is the average speed. In what case? If a body covers, yeah, equal distances with different velocities. And this special formula is known as harmonic mean of the velocities. So the average velocity or average speed here will be equal to the harmonic mean, 2 times V1, V2 divided by V1 plus V2. Okay. If different is the case, if the particle or the body moves with velocities, if V1, V2, V3 are the velocities with which the object moves with time interval T1, T2, T3 and so on. Now velocities are given and the time intervals are also given. We have to calculate average speed. Everybody knows that average speed is total distance covered by total time. टाइम तो दिया है लेकिन डिस्टेंस यहाँ पे नहीं है. How we can calculate the distance? Yeah, same is the formula. Since velocity is distance by time, distance is equal to velocity into time. So let S1, S2 and S3 be the distances. So that will be equal to V1, T1. Yeah, S2, V2, T2, S3, V3, T3. So average speed, yes, in this case will be equal to, that is V1 T1 plus V2 T2 plus so on divided by T1 plus T2. Okay, in this case students, remember, if T1 is equal to T2 is equal to time T, say, so the particle moves with the different velocities in the same intervals of the time. So under those conditions, the average speed will be, yeah, It is V1 t plus V2 t. Take out t common. V1 plus V2 into t divided by T1 t, T2 is t, that is 2t. T and t will go. So this is V1 plus V2 divided by 2. So what is the formula for calculating the average speed? It is, yes, arithmetic mean of the different velocities. So remember two formulas for calculating the average speed. One is, it is equal to harmonic mean of the speeds, and why we have to use it, we'll be talking about it in detail. And this is the second formula for calculating the average speed, that is the arithmetic mean of the different speeds. Second part is regarding the velocity. Velocity is rate of change of displacement. Yeah. Velocity is basically the displacement covered divided by time taken. Yeah. Since displacement is a vector quantity, so on the basis of that we can write here velocity is also a vector quantity. Its unit is same as that of the speed. Its unit is meter per second or centimeter, meter per second or centimeter per second. Its dimensional formula is same as that of the speed. There is only one difference between speed and the velocity. Speed is a scalar quantity, while as velocity is a vector quantity. Other things, the units, the dimensional formulas are same. Okay, students, this velocity is also divided into two categories. So, one type of the velocity is known as uniform velocity, and second is known as non-uniform velocity. I have already discussed it in case of the speed. So if the velocity of an object is non-uniform, that is the object covers equal distances in unequal intervals of time or unequal distances in equal intervals of time. Okay, so non-uniform velocity, we calculate average velocity, and then we calculate instantaneous velocity. Okay, the average velocity will be, yeah, total displacement divided by total time, total displacement divided by total time, and instantaneous velocity, as I have talked earlier, the instantaneous velocity is nothing but it is the first derivative of displacement. Yeah, velocity at any instant of the time. Now the question is, my students, if the body is moving with uniform velocity, what will be the velocity time graph? In my previous lecture, I was talking about the speed. Speed of an object can be positive, okay, while as velocity of the object can be positive, it can be negative, it can be zero, okay. So this is time and this is the velocity. This is taken as positive velocity above, and this is known as negative velocity. So in case of uniform velocity, the velocity time graph will be a straight line, yeah, exactly, parallel to the time axis. If the object is possessing the positive velocity, if the negative velocity, it will be below the time axis but will be parallel to the time axis. Okay. From this graph, the velocity time graph for uniform motion is a straight line parallel to the time axis. From this graph, what we will get? Suppose the object is in motion from this time to this time. Okay. At one interval of the time, call it T1, its velocity will be, yeah, it will be, call it as V1. And if it is having uniform velocity, at the time, second interval of time, what will happen to its velocity? Velocity will remain same. Let us call these intercepts as A, B, C, and D. So, students, from this graph, what AC represents? AC represents basically OC minus OA. That is T2 minus T1. So AC in this graph represents the time, that is T2 minus T1. While as AB represents, it represents the velocity. Can anybody tell me what is AC cross AB? AC into AB will give us, AC is time, AB is velocity, velocity into time, you are right, that will give us displacement. So this velocity time graph gives us displacement. And can anybody tell me displacement is equal to, from this graph, it is area of velocity time graph, or the area of shaded portion will give us the displacement between these two intervals of the time. So remember, area of velocity time graph gives us displacement. Will it give us distance? Yeah, it will also give us distance, because in one-dimensional motion, the displacement is also equal to the distance. But you have to remember one thing. If we are talking about the negative velocity, there we will get the distance, but we have to neglect the negative sign. In this uniform motion, the position time graph. Let's take time along x-axis, and the position of the particle along the y-axis. The position time graph will be a straight line sloping in the upward direction. Remember it. For uniform velocity, if the object is moving with uniform velocity, the velocity time graph as well as this position time graph, uniform motion में, तो position time graph will be a straight line sloping in the upward direction. I am talking about uniform motion, and I am talking about the position time graph. While as in my previous lecture I talked about the position time graph for an object which is at rest is a straight line parallel to the time axis. Okay, now I am talking about position time graph of an object which is having uniform motion. Okay, it is a straight line sloping in the upward direction. Can start from the origin, from right side of the origin, or from the left side of the origin. Okay, so let's take one interval of time as t1. Corresponding to this time, there is one position of the particle, call it as x1. Okay, now time will change to t2, and corresponding to this time, let us call the position is x2. Let's call this as A, this is B, C, D. Okay, on producing this graph here, let's talk this angle is equal to theta. So what we will do, we will draw here a perpendicular from B to this line. So this angle is also equal to theta. Okay, name this point as E. In right angled triangle, BED. What BE represents? Think about it. So this B is basically AC. What is AC? AC is OC minus OA, that is T2 minus T. Okay, this represents T2 minus T1. Exactly. So what this DE represents? DE is basically CD minus C. DE is CD minus C. What is CD basically? CD represents the position, final position. This, it is x2 minus x1. So, can anybody tell me, in this triangle, this DE by BE. Yeah, I'm talking in triangle BED. So, DE by BE, yeah, exactly, you know, it is tan theta. But what is DE, my students? DE is x2 minus x1. So, x2 minus x1 divided by, what about BE, that is T2 minus T1, is equal to tan theta. So, what is x2 minus x1? x2 minus x1 is, yes, final position minus initial position. That is displacement. divided by time. What is that? Yeah, that is the velocity, which implies tan theta is equal to velocity. So what is tangent of the angle? Tangent of this theta. That is the angle that this line, the graph, makes with the positive direction of x-axis. We call it as slope. Slope of position time graph gives us, yes, slope of position time graph is equal to tan theta, gives us velocity. So remember, in uniform velocity, uniform motion of an object, the position time graph is a straight line sloping in the upward direction, and the slope of the position time graph gives us velocity, and slope of the graph is equal to tangent of the angle that this graph makes with the positive direction of x-axis. Slope of the graph is tan theta, that gives us the velocity. So try to remember one thing, the position time graph gives us velocity. Basically, the slope of the position time graph is equal to velocity, and the velocity of time graph gives us the displacement. Displacement is basically the area under velocity time graph. Thank you.